TG. This is lesson 3.6, solving systems using the matrix method. You have just watched a video that demonstrates to you what a matrix is and how to find the dimensions of a matrix. Now we're going to use that to help us calculate the point of intersection of this system. Now to use the matrix method, well, first of all, you've used substitution to find that point of intersection, graphing, elimination. Those are three techniques we've used. Now we're going to use our calculators. So what I need you to do is pull out your 83 or 84, and we're going to demonstrate how you can actually use that to create the answers on your calculator. In order to do that first, though, we have to make sure that both equations are in standard form. So let's go through that process. If we look at the top equation, it is in standard form, ax plus by equals c. So 4x minus 12y equals -1 is in standard form. So that's okay. So let's write that down. 4x minus 12y equals a -1. The bottom one, however, is not in standard form, so we're going to have to add 4y to both sides and just simply list the terms in the order that we prefer for it to be in standard form. So it looks like this. That's the bottom equation. Now, what we're going to do with this bottom equation, and I want you to look at what I have here, compare the system to the matrix that I have created. Here it is. You'll notice that the first row, the first column of the matrix are your x coefficients. Your second column are your y coefficients. And these are all your c terms, -1 and 4. And while I'm thinking of this, if you're missing an x term, let's say if this top equation didn't have an x term, you would make sure you fill that in with a 0. Now what we're going to do, you need to remember this matrix right here, this one right here. We are going to put this matrix in our calculator, and it's going to find the point of intersection of the matrix. So pull out your 83 or 84, looks like this. We're going to enter that matrix into our calculator first. Make sure that everything's cleared out of your calculator. There should be nothing here when you hit the y equals, no equations. There shouldn't be any scatter plots turned on. They should be all turned off. Now what I need to direct your attention to is above the x to the -1st power button right here. We need to go above that. If you see that, it says matrix. Second matrix, and you'll see that we have the capabilities of storing up to 7 matrices and calling all these different letters. Now the first thing we're going to do is just call this one matrix A. We're going to edit it. You know, we have all these operations available. We can name it, we do some math operations, or we can edit the matrix. Highlight the word edit, then enter. And you have the capability of actually changing the size of the matrix. Now, the first number is the number of rows in your matrix, so you hit 2. You'll notice the calculator automatically shrinks it down to 2. And we're okay with a 3 because we have 3 columns, so we'll enter there. And then you enter in all the numbers in your matrix. And I've already done this, but you just enter, hit enter. Once you enter the number in, it's going to appear down here. Then once you hit enter, it just basically will put it in that location. And then move on to the next element, but make sure it matches ours completely. So we've got matrix A stored that represents our system of our equations. Now let's quit and let's go back in to the matrix menu. This time we're going to do a math operation. So highlight math, go all the way down to, it says RREF. There it is. This stands for reduced row echelon form. It is something, if you move on to pre-calc, they'll talk more in detail about what that means. But what we're going to do is pull that up. It's a function that's going to help us calculate this system. You enter. So you'll see reduce row echelon form pop up. Now we have to name the matrix we want to carry out this operation, and that's matrix A. So we go back into second matrix. This time we're going to keep it on name, and we want to name it matrix A. So you just enter one more time, and you'll see a list of numbers. Now, if you have a solution to your system, you will see ones in what I call the main diagonal of this 2x2 matrix. There should be zeros over here. If there is no unique solution, if these lines were parallel, you would not see this. This is called an identity matrix, 1, 1, 0, 0, 1. Okay. Basically, your answer is located right here. X equals 0.5, Y equals 0.25. That is going to be the solution of your system. So you can simply write that down. You would simply write that as, in your notes, X equals 0.25. Let's go back and look at that again. We're looking at X equals, let's go back in the large screen. So you can see X is 0.5 and Y is 0.25. That would be the solution to your system of your equations. 0.5, Y is 0.25. This would be the same exact solution that you would obtain if you solve this by graphing or substitution or whatever method you picked. The only disadvantage of using a calculator is you cannot determine if the lines are parallel or if there are many solutions or if there's no unique solution. You can't distinguish the difference between those special systems, but you can find the point of intersection. So hopefully this went well. Good luck with this. Now we have one more lesson on, it has a word problem, so please stay tuned to that.